Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally, a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to the latest video, and in this video newsletter we are going to talk about robust settings found the Taguchi way. Okay, so we're going to talk about Taguchi robust design of experiments. Now, this is the result of a question that someone's asked me. I checked my video list on YouTube, and amazingly, I don't seem to have covered this before, which is quite startling to me. But anyway, I'm going to talk to you about how Taguchi used to set up a DOE so that he could find robust settings. Now, the important thing about this doesn't need a Taguchi based DOE pattern to be run. You can do this with any DOE pattern, a full factorial, a half fraction. You can use the Taguchi screening DOEs, the L12, the L8. You can do this with any pattern you care to do, because it's just a special method of setting up the DOE. And by the way, you know, the idea that Taguchi is a kind of a DOE practice on its own seems a bit strange to me. Taguchi is just part of the DOE suite of approaches, and if you do a Taguchi DOE, it's just a design of experiment. It's just a different pattern, and you just have to understand that. So let's talk about how we find something called robust settings in design of experiments. Now, basically, let's treat this as if it's an ordinary full factorial. So we're going to go 2 level, 2 factor, full factorial, but it's going to have robust analysis attached to it. All right, so the two factors, we're going to take time at 5 and 10 seconds. We're going to take temperature at 70 to 90 degrees centigrade. Now the thing that we want to be robust to is outside humidity. All right, now clearly when we do the DOE, I can control these two. Outside humidity, unfortunately, there is no dial for it. So even if I could put this into a designed experiment, I don't have a dial for humidity, so I can't say that this is the way I should set humidity. So what I need to see if one of these two can provide me with robust settings to be robust to humidity, so that it doesn't matter about what the humidity is outside, the process is going to be robust to it. So let me show you how that works. Now, if we just take the 2 factor full factorial for a second, that's going to look like this. So you're going to go, so factor A, 5 and 5, 10 and 10, factor B is going to be 70, 90, 70, 90. So that's the experiment that we're going to run. Now, of course, we haven't got humidity in this experiment. We haven't got humidity in this experiment because I can't put it here. So I can't make it a 3-factor full factorial. But what I can do is allow humidity into this experiment in a very special way. And this is what I'm going to do, look. What I'm going to do is I'm going to collect a results. I'm going to collect a results table. And what I'm going to do is this. I'm going to suggest 3 columns of data. So in other words, I'm going to run this DOE on 3 different days. Now we will have decided what the outside humidity is, so we'll decide what the outside humidity is giving us a problem. And then what I would do is this. I'm going to come to work, and when I consider that the humidity is a lowish level, so I can't be certain where it's going to be, but I would pick a value for the humidity, then I'll run the process and I'll measure the results that I'm interested in. Let's say that this product eventually produces a strength result for the product. Okay, so I'm going to measure the strength, produce the products, measure the strength when humidity is low. Then what I'm going to do is when I come to work one day, I'll measure the humidity every day. If I decide now that the humidity is somewhere in the middle, again, I can't be exactly certain, but I would have decided this before I started. When the humidity is somewhere in the middle, we'll run the DOE again and we'll measure the strength of the products produced. And then finally, I'll come to work, and when I consider that the humidity is at a high level, I will run the DOE again and collect some more results. Now what you're doing by building in, and this is Taguchi's methodology, what you're doing by building in Taguchi's methodology on the end of your experiment, you are basically doing the experiment 3 times, because you're having to run the full setup 3 times. Now we've got the results. Now where does the robustness come from? Well, the robustness comes from this. What you're going to do now is you're going to analyse for variability. So what you'll end up with is typically a standard deviation value. Standard deviation value. End up with a standard deviation value across the 3 sets of results. So you're going to analyse the variability. Now when I do this, I always analyse standard deviation. So I treat standard deviation in exactly the way as I would treat the mean, and I analyse it and I model it. Now there's 2 ways you can do this. You can then use the model to minimise standard deviation, because if you have very little difference across these 3 results, this particular setting must be robust to external humidity. So in other words, if you can use the model, reduce the standard deviation to an absolute minimum, that must be a setting which is robust to outside humidity, because despite the change in humidity, the results didn't change. So you can do it using a model, or you could just pick a winner. So you could just look across the 3 results, decide that setup 3 has got the minimum amount of difference in the data set, decide that that is the robust setting, and you could now just pick this as the setting that you're going to use. Now this possibility to identify robustness just from without doing a model, just by using graphs just using simple ways of doing this without including the variable in the actual full factorial itself. This is Taguchi's methodology, because noise, generally, you want to be robust to noise. What's the problem with it though? You can't control it. So although there are fancy ways of finding robustness with a full factorial by analysing the two-way interactions, often you can't put the noise. I can't put humidity in a DOE. I can't control it. But I can allow it to appear in the data table, travelling in that direction. Then I analyse to minimise standard deviation, and if I can do that, those settings are robust to humidity. And that's the way Taguchi did it. I personally don't use a lot of what Taguchi did back in the day, but some of the things he gave us are simply genius and should always be added to any design of experiments, whether it's a full factorial, a fractional factorial, or whether it's a Taguchi design itself, because that is superb. And I've seen some exquisite designed experiments that have switched variables off. You can literally switch a variable off and make a process robust to external noise. That is robustness Taguchi's way.